lovely to see so many people here in attendance today. My name is Rosemary Davis, and I have the great privilege of being the Director of the Arts, Sports and Initiatives area in the Department of Education. And just in terms of the team I oversee, 2016, Arts and Sports provided 1,300,000 experiences for students in New South Wales public schools, which is an outstanding effort. They also provided 67,000 experiences and opportunities for teachers as well in our public schools. In terms of the sport portfolio, those experiences include the state knockouts, the regional sporting competitions across New South Wales. We have overseas trips that kids participated in, and also the Premier's Sporting Challenge, which is part of what we're here today for. And this year in the Premier's Sporting Challenge is the largest amount of kids that we've ever had, which is fantastic. Before I begin and introduce Professor Hillman, can I just acknowledge the traditional custodians of the land that we meet here today, the Wongal people, and pay my respects to elders past and present, and any Aboriginal people in the audience today. The New South Wales Department of Education is very pleased to welcome Professor Charles Hillman, or Chuck as he's known, from Northeastern University, Massachusetts to Sydney. There's no more American name than Chuck, and I hope you haven't heard what the Australian vernacular is for the word Chuck over here. But we do love a good nickname, and you don't get much better than Chuck. The format for today is that Professor Hillman will speak to us for about 50 minutes, and then we'll have some time for questions from the audience. And that'll take up about 20 minutes, but you'll be out of here by around about 3 p.m. Can I also just acknowledge that this has been live streamed today, so welcome to any of the people that have logged on to watch the presentation. And we will also have assets from this. Professor Hillman has been very kind to say that we can use any of his material to provide and support teachers and other government agencies around this really important research that he's done. So, can I also just acknowledge the help and a thank you to Professor Dave Lubens from Newcastle University. Without him and his university bringing Professor Hillman out here, we wouldn't have had this terrific opportunity. And could you also pass on my thanks to the Vice-Chancellor as well? Really appreciate that. And could I also just thank my team, Ross and Roz and Sue, who put this program together for us today. All right, so Professor Hillman is a member of the USA Committee of Physical Activity Guidelines that promote minimum daily levels of physical activity for maintaining healthy lifestyles. Professor Hillman directs the new Centre for Cognitive and Brain Health at Northeastern University, which has the mission of understanding the role of health behaviours on brain and cognition to maximise health and well-being and promote the effective functioning of individuals across their lifespan. Dr. Hillman has published over 160 research papers across the topic. Professor Hillman has served on the US Institute of Medicine National Academics Committee entitled Educating the Student Body, Taking Physical Activity and Physical Education to School, and as previously mentioned is currently a member of the 2018 Health and Human Services Physical Activity Guidelines for the Americas Advisory Committee. His work has featured in the media, including CNN, National Public Radio, Good Morning America, Newsweek, and the New York Times. And he's one of the only people that hasn't been on Ellen or Jerry Springer. The professor practices what he preaches, applying his research findings to his personal life, When he's not studying the relationship between physical activity and cognitive health, he's biking, playing ice hockey, or lifting weights. Please make welcome Professor Hillman.
Thank you. Okay. Is that it? No? There you go. Okay, good afternoon. Thanks for having me. I'd like to begin by thanking Rosemary for that introduction. Hopefully I won't be seen around town tonight where people might say that Chuck's chucking. I'd also like to thank Ross and certainly my colleague Dave Lubens and the University of Newcastle for having me out. I've had the full experience this week, and so maybe with that, rather than tell you about my full experience, I might just simply say at this point I'd like to change my title to Surf for Your Life, because it might be more appropriate here than Run for Your Life, although I'm sure that that's probably appropriate as well. And so children are becoming increasingly sedentary. This should not be a surprise to anyone. By example, if you look at the United States and you look at leisure time physical activity by county, you can see that there is a portion of the United States where a third of the population reports no physical activity at all in their leisure time. This is certainly quite alarming, as we know that there are a host of benefits to being physically active. But when it comes to children, what we know is that there's an increased prevalence of being overweight and unfit that accompanies being physically inactive. And if we were to just take an example here for a second, you can see over a 25-year period from 1990 to, I think it's 1985, 2010, you can see that the nation has moved from being more lean to being more overweight and obese. And along the right here, I've taken snapshots of 2003, 2007, and 2011, and these are just school-age children, where you can see that they're not immune to physical inactivity and childhood obesity issues. Now, the problem with being physically inactive is that sedentary childhood tends to lead to sedentary adulthood. We learn our physical activity behaviors, for the most part, as children. Now, it's not to say that we can't pick up new behaviors. I learned to surf this week, but you don't have a whole lot of time to practice it. If you consider that as an adult, you have a lot of other responsibilities, not just work or vocation, but certainly to your family and your child's physical activity behaviors and those sorts of things. And so certainly it's easier to pick up these behaviors as a child and develop efficacy that we take throughout the course of our lives and through adulthood. Given our new president, I need to include this slide, I guess, that if alarmingly, when the United States has through the Department of Defense and certainly the various branches of the military, has a new or two publications out, one called Too Fat to Fight and the other called Too Fat to Fight 2. And just a couple of the statistics is that about a quarter of our military age individuals are overweight, too overweight to serve, and they've spent, and this is an old figure, but more than $1 billion already on weight management of our recruits. But for everyone, there's been more recent estimates that have indicated that this generation of children in the United States will be less fit and less healthy and have shorter lives than their parents. And that marks the first time in U.S. history that this trend has occurred. And so it's actually, we're seeing shorter lifespan. And not to give away the punchline too early, but making matters worse, a growing number of schools are eliminating daily physical activity opportunities. And so if children are to get, children to learn about their physical activity behaviors in their youth and carry it through their adult lives, school becomes an important place in which to do that, just like it is for math or reading or what have you. And so the knowledge that kids gain early in lives and the behaviors they develop should be benefited by schools rather than hindered. And so if you look through the literature, and I can tell you I have, there's two scenarios that emerge from the literature. When you look at physical activity and its relationship with academic performance, we see one of two outcomes. Either there's a beneficial relationship such that kids who are more active also perform better on academic tests, that's certainly a win, or there's no relationship. And so what that means is that if if more physically active kids don't show any better performance in schools, that's still a win. Because what you have is you have a more active individual, a more healthy individual at no cost to educational attainment. There's next to no literature in the field that suggests that being more physically active relates to poorer school performance. And so here's some data from our own laboratory. These are data collected in 3rd through 5th graders. And what you're looking at along the x-axis here is the number of times in which a child passed or fell in the healthy fitness zone for the FitnessGram fitness test, which is conducted typically in PE classes. And so the FitnessGram is comprised of a cardiorespiratory fitness test called a shuttle run or a pacer test, tests of muscle strength, push-ups, curl-ups, which is similar to sit-ups, a measure of flexibility in a hamstring, sit and reach, and then body mass index. And so you can see here there's a relationship between the number of times in which they passed the tests of the FitnessGram with their performance on the Illinois Standardized Achievement Test of math and reading. And that scale goes from 200 to 400. The more tests they passed was related to better performance on the standardized achievement. We broke it down and looked at their performance on the various different fitness tests. We found that the PACER test, or that cardiorespiratory fitness test, was most related, such that with an increased number of laps run, we saw an increase in academic achievement. There we go. Is it? Yeah, there it is. And when we look at muscle strength and muscle flexibility, there was no relationship. And when we look at body mass index, we see a small but negative relationship, such that with an increase in BMI, we're seeing a decrease in academic performance. And so these are just relationships, but certainly they suggest that both the physical health and the academic health of an individual are related. Now, my laboratory goes beyond academic achievement. Most of our interest is in brain and cognitive outcomes. And so with that, I'm just going to give a quick lesson on sort of my vision of the brain and its plastic nature. And so you've probably heard that the brain is plastic, it's malleable. Old dogs can indeed learn new tricks. We now know this. And so plasticity, when it's used, is referring to our ability to adapt to change in our environment. And what we're really talking about is the ability to create, my computer and the screen are not set. And so what we're talking about is rapid modifications between structures within the brain. And so certainly there's a genetic component, and I'll just leave it at that. But what I'm really interested in is the environmental component. And a colleague of mine who recently passed, was at the University of Illinois, named Bill Greeno, he talked about experience expectant and experience dependent influences. Experience expectant influences are those that are typical to a species. And so, for instance, when children are born and you have an infant in the crib, you give it mobiles. And those mobiles are typically black and white checkered because it's been shown that exposure to different gradients and shades of color and objects and motion is good for the developing visual system. There's other work by Heldon Hine in cats that shows that if you rear cats in darkness during this critical period, their visual system doesn't develop, typically, in a typical fashion. But experience-dependent influences, these are influences that are atypical. That is to say that they're not typical to the entire species, but rather they're more the idiosyncratic experiences that we have. And so, for example, to learn to surf as a young child probably has benefits to their ability to balance throughout the course of their life if they were to maintain that behavior. And so when we look across the literature, there's all kinds of examples of plasticity in the brain. For instance, vocation. There's terrific work that shows that London taxi drivers have greater hippocampal structure and function, a part of the brain involved in learning and memory, than London bus drivers. And this makes a lot of sense because the hippocampus is involved in spatial aspects of learning and memory, and taxi drivers need to be able to navigate the city in time and space in order to get their passenger from point A to point B. Bus drivers, they don't do that in the same regard. There's no flexibility there. They're running the same route every single time. And so the benefits of that exposure as a taxi driver have benefits to brain. Music, we know that being the conductor is better than being in the orchestra, and being in the orchestra is better than being a knowledgeable listener. Sport, my advisor, Brad Hatfield, showed that the brains of elite marksmen were related to differential function than the brains of lesser elite marksmen or novice shooters, and that had relationships with attention. And then there's good work around juggling. And so much of my work has been centered around this question of, well, why not health behaviors, such as physical activity, the ability to accrue aerobic fitness, diet, adiposity, or overweight and obesity. And so why not that these health behaviors would also have relationships with brain and cognition? And so with that, I'm going to first talk about brain structure. Most of this work is cross-sectional, and what I'm looking at here is a relationship between fitness and the size or the volume or the amount of certain structures within the brain. And so, for instance, this is an image of gray matter. The brain is comprised of gray matter and white matter. Gray matter is our neurons. White matter is the connective tissue between neurons. And these are data in high and low fit kids. And what we can see is that high fit kids and low fit kids differ in certain regions of the brain. In particular, as you can see here with these stars, the lateral occipital cortex, the superior temporal cortex, and the superior frontal cortex. Superior frontal cortex is interesting because we know that it has a relationship with math performance. And actually, in this particular sample, we saw that the better kids were in math, the less tissue they had in superior frontal cortex. What we also saw was that the higher fit kids had less tissue in superior frontal cortex than lower fit kids. And many of you might be saying, well, what are you talking about here? Why less? And it's the idea that less is more. And so throughout the course of development, kids gain a lot of neurons. And then as they learn behaviors, there's a process of elimination where only those pathways that are important to their behaviors survive and the rest die off. And so cortical thinning, as it's called, is actually a typical part of maturing. And what we see is that higher fit kids appear to have the looks of a frontal cortex that is more similar to that of an adult than lower fit kids. Here's other data that is imaging white matter, the connective pieces of the brain that allow transmission of information between different areas within the brain. And what we find, just briefly, is that higher fit kids have increased white matter, greater integrity of those connective structures in the brain compared to low fit kids. And we see this across a whole host of different areas, from the corpus callosum, which is the major connective tissue that connects the left and the right lobes of the brain. And so many of our tasks actually also, many of our brain imaging projects also include a task. And so I told you just a couple minutes ago about the hippocampus. And we're particularly interested in the hippocampus because the hippocampus, as I said, is involved in learning and memory. In particular, it's involved in a type of memory called relational memory or associative memory. And this is memory that we use to bind elements of our environment together in order to recall a subsequent scene or environment that we've been a part of. And so, for instance, this is a scene of a cocktail party. If you've been to a cocktail party, you will recall that maybe when you had a lot of fun, you're trying to recreate that night in your head. You can think about who sat to your right, who sat to your left, what kind of wine they drank, what they ate, who said what, and that allows you to remember that environment. And that's because your hippocampus is hard at work remembering these details. And as we talked about before, certainly navigating through the streets of Sydney can be quite challenging, and if you can remember your way from point A to point B, that's because your hippocampus is, again, hard at work. And so here we have data. These are new data in high and low fit kids, and what we're doing is we're imaging hippocampus here. And you can see that high fit kids have considerably more volume in the hippocampus, considerably more structure to the hippocampus than low fit kids. What's interesting is that when we look at tasks of memory that either tap the hippocampus, require they're hippocampal dependent tasks, or don't. This is a type of memory that occurs outside the hippocampus. What we find is selectivity. That is to say that not only do higher fit kids have greater hippocampal volume than lower fit kids, But what we find is that they also perform better on tasks that require hippocampus, and there's no difference in groups when we look at tasks that don't require the hippocampus. I didn't say it before, but let me just pause and say that, that all the kids that I'm studying that I'm going to talk about today are somewhere around 8 to 10 years old. Usually they're 8 to 9 or 9 to 10. We keep a small window. And we measure all kinds of factors. Age, sex, SES, IQ, and pubertal timing are the big 5 measures for us that have relationships either with physical activity or with our cognitive or brain outcomes. And so all of those are accounted for in the data today. But certainly during questions, I could talk about other aspects of that if you want. Now, much more commonly in our laboratory, we spend time studying executive control. Executive control relates to our ability to regulate and regulate behaviors and meet desired outcomes and intended goals. That is to say that this is the complex cognitive or complex aspects of cognition that we perform every day in order to achieve some goal. It's not habitual or it's not instinctive. It is a challenging part that we do that's purposeful. And so, meaning that, that in order to perform a math problem, there are purposeful cognitive operations that occur in order to seek that answer. It's not just a habit. And so, while we can talk about executive control in all different ways, I'm going to define it today according to 3 different aspects of cognition that sort of comprise executive control. The first is inhibition. This is our ability to ignore distractions, stay focused. Kids do this every day in the classroom when they have to pay attention to the lesson and maybe the kid at the desk next to them is talking and distracting. They have to gate that out and focus on the lesson at hand. Working memory, it's our ability to ignore, it's our ability to hold information in our mind and manipulate it. And so this is important, for instance, in carrying the remainder during a math problem or reading a passage and having to answer questions on that passage. And then cognitive flexibility, which is our ability to switch perspectives or focus. It's oftentimes called multitasking, right? We perform one task, then we inhibit that task. We perform a second task, then we inhibit that task, and we go back and forth. And everyone thinks they're very good at multitasking, but we know we're actually not that good at it. And this is why campaigns for texting and driving are so important now, right? We use executive control all throughout our life. When problems are novel, we have to plan our actions or problem solve. And it's important for mental health and physical health, our quality of life, for school success and school readiness, job success, and certainly marital harmony. And so in all cases, you use executive control throughout the course of your life. And so this is just a quick example of part of the executive control network within the brain, the basal ganglia. Again, we're looking at high and low fit kids. And what we see is that certain regions of the basal ganglia, this is a subcortical structure that's involved in the interplay of cognition and action. And so you could argue that this might be one of the regions of the brain that puts thought to behavior. And regions of it, like the caudate nucleus, the putamen, and the globus pallidus, these are involved in executive control. They're part of that executive control network. And in all 3 of those regions, we see that higher fit outperform lower fit, or not outperform, but have greater volume, as you can see here. But the nucleus accumbens is kind of our control region in this case. The nucleus accumbens is not involved in executive control. In fact, it's involved in other processes such as affect and reward seeking. And what we find is that there are no differences in high and low fit kids, suggesting, again, some level of selectivity in the regions of the brain that are influenced by fitness. And so using the same task that I just showed you in the magnet here, this is a task of inhibition and a task of working memory. And you can ignore the top graphs. These are just showing the tasks themselves. We'll just stick to the bottom so I can show more data today. This is, again, our fitness gram, looking at cardiorespiratory fitness through a shuttle run. Less laps, more laps run. These are 400 kids who are, these are actually 7 and 8-year-old kids. There's 400 of them about, I think 397. And what we find is that with more laps run, we see faster and more accurate responses on tasks of inhibition and more accurate responses on tasks of working memory. Now, when we followed up on these kids 3 years later and now we only have 290 of them, just paying attention to the bottom here, what we see is that those who have an increased change in fitness, that is, they become more fit over the course of those 3 years, perform better on this task of inhibition, they're more accurate, and better on the task of working memory. However, importantly, what we find is this relationship only occurs for the task components that require greater amounts of executive control. The task components that have lesser executive demands don't show that relationship 3 years later. So greater amounts of fitness were related to task performance only when greater amounts of executive control were required. Now, I've spent the last 10 years of my life studying brain function a number of different ways, but today I'm going to talk about the Fit Kids randomized control trial. The first 5 years was the Fit Kids trial. The second 5 years, which actually ends in the next week or two, was the Fit Kids 2 trial. And I'm only going to talk about Fit Kids 1 today because this is the only one where the data is complete and published. And this was an after-school physical activity program that we created when we were at the University of Illinois, and it was involved with kids in Champaign schools. And kids came to the laboratory in the summer before the school year, and they performed 10 hours of testing in our laboratory over multiple days. And then they were randomized to either the after-school program, the Fit Kids program, or to a waitlist control group. And then the kids in the after-school program, they were bused to our intervention site on campus every day that school met for an entire school day. And so over the 9 months, 150 of the 170 school days, children were bused to our intervention. At the end of it, we had 221 kids with usable data out of 252. And for those in the intervention, in the 2 hours that they were with us after school, they spent about 70 minutes engaged in intermittent, moderate to vigorous physical activity. That equated to just shy of about 5,000 steps in that 2-hour window every day. There was efficacy in the intervention, as can be seen here. Those in the intervention improved their fitness by about 5.5%, and those in the waitlist control group, which comprises typical development over the course of 9 months, improved by less than 1 percentage point. Now, when we, let me say, before I jump into the data, that these kids were not high-fit kids to begin with. We recruited any kid that came to our lab that met our criteria, and without recruiting for adiposity, overweight and obesity, or for low fitness, when we looked at that sample of 221 children, 60% were overweight or obese, and 66% fell in the bottom 3% for fitness. And so what we're talking about here is taking a low-fit kid and making him slightly less low-fit. We're not talking about making him high-fit sprinters, marathoners, what have you. This is a small improvement in fitness that still would characterize a child as low-fit over the course of 9 months. And so these are the tasks of inhibition, the flanker task, and this is the task of cognitive flexibility, our switch task. And what you can see is that from pre-test to post-test, the change score, we find that kids in the intervention improve their performance on these tasks by about 7.5% and 10% over the course of 9 months. And those in the waitlist control group improved by about half that much, so just shy of 4% and about 6% over the course of that time, suggesting that, or indicating that those in the intervention who received the physical activity dose 5 days a week had better performance 9 months later. When we looked at brain activation, now we're not looking at MRI data, we're looking at ERP data, event-related brain potential data, and this captures the electrical activity of the brain. It's a direct measure of neuronal activation, and in particular, we're interested in these sort of hot spots we can see here. And you can see the scale, red is more. And what we find in our change from pre to post is that this particular potential, called the P3, is enhanced in kids in the intervention compared to their counterparts in the waitlist control. Now again, importantly, what we see is that this effect only occurs during task conditions that require greater amounts of executive control, as you can see here. And importantly, this potential, this brain function, is associated with the allocation of attentional resources. That is to say that, this potential is derived when you allocate attentional resources externally to your environment. And so, for instance, if we're sitting here and someone bursts through the door and you have a quick look and you go back, you've allocated a P3 that's directed your attention towards some stimulus in your environment. And so this is the amount of attention being allocated to the different stimuli that they're seeing when making these decisions on these tasks. And so what we found was that there was an increase in brain function that underlies attention and an increase in cognitive performance as a function of being in the intervention compared to being on the wait list. Now, if we consider just the children in the intervention now, forget about the wait list for the time being, what we find is that those who attended more, as you can see here on the x-axis, had greater change in that P3 potential, so greater increase in allocation of potential resources, and a greater improvement in performance, greater accuracy, suggesting that they had to be present in the intervention in order to derive the benefits of that intervention. And I think this is similar to what teachers say, that you have to be present to learn. And so one more bit of data was, this is what gave rise to FitKids2. This is fMRI data, functional magnetic resonance imaging data. It's a different version of our flanker task here with arrows instead of fish. And what you're looking at here, this is the prefrontal cortex. And these are kids in the wait list. From pre to post, activation in that prefrontal cortex doesn't change. When we look at kids in the wait list, in the intervention, we can see from pre to post 9 months later, they show decreased activation in the prefrontal cortex. What's interesting is these are young adults. This is our young adult control group. And we find that those in the intervention 9 months later have a decrease in activation that's more similar to young adults, to a typical young adult model. Young adults are an important comparison group because this is when we're at our cognitively most healthy. I didn't say this before. I don't want to alarm people in the room, but it takes a long time for executive control to kick in, to have a fully functioning prefrontal cortex that allows you to be a good executive functioner until about the age of 20. But by the time you're 30, your prefrontal cortex is already decaying, and as is your executive function. And so I could say things twice for some of you maybe if I need to. Or maybe for myself, right? And so not only do we see changes in brain function that's more similar to an adult-like brain after intervention, but when we look at behavior, we see the same thing. This is the waitlist control. They're 9 months older. They've seen the task before. They get a little better. But this is the intervention group. And you can see that they're statistically no different from the young adult group. They're no different from the waitlist either, but they're no different from the adult group. And so with that, I'm going to switch gears and I'm going to talk about different type of exercise stimulus, and this is a single dose of exercise. And we're asking questions about what does one dose of exercise do for cognitive performance for a short period of time. And this is very much motivated by what can be done in the classroom. I know it's hard to have kids go exercise every single day, but if you could benefit children's academic performance through one bout of exercise for a short period of time, you have to ask yourself whether or not that would be an interesting thing to do in your classroom. And certainly I'm going to argue that that's the case. We took 20 children. They're 9 and 10 years old. They came to the laboratory on a couple occasions. On one day, they walked on a treadmill for 20 minutes at 60% of their max capacity. This is a very moderate walk. You don't build a sweat. Every kid can finish it. It's a very moderate pace to walk at. And on the other day, they sat in a chair. At the end of those 2 20-minute sessions, we then measured brain function using our inhibition task, that flanker task. And we measured their cognitive behavior, and then we measured their academic performance. And you can see here, this is the most difficult condition, the incongruent condition of a flanker task when it requires the greatest amount of executive control. Following that bout of exercise, here's what this increase in P3 amplitude. They're allocating more attentional resources after that bout of exercise compared to when they rested. And when we look at the lesser executive task, the effects have been diminished. Now, I also include the waveforms here because if you compare this dashed line right here with this dashed line, and this blue line with this solid line with this solid line, the orange is our exercise intervention. And what you can see is that these peaks occur earlier. This is our P3 component. And the timing of that component is a metric of cognitive processing speed. The earlier it appears, the faster they're processing information. And so not only are we seeing enhancements in their ability to allocate attentional resources, but we're also seeing faster cognitive processing speed following that 20-minute bout of walking compared to rest. We replicated this, again, I'll just show you quickly with children with ADHD, same effect, more P3 amplitude, faster latency after walking compared to sitting. When we looked at behavior, you can see that they performed better after exercise compared to rest, and at no cost to speed. And we gave them a task. When we gave them an academic achievement test, these are now both ADHD and typical kids lumped in together. What you can see is that they perform better on academic achievement tests of reading and arithmetic following that bout of walking compared to following a bout of seated rest. So single bout of exercise is efficacious in promoting better brain function, greater cognitive performance, and better academic achievement. Now, some of the work that brought me or Dave Lubens and I together is our interest in high-intensity interval training. I understand that 20 minutes of walking in the classroom might be rather difficult, so what are some other solutions? Well, here's high-intensity interval training, HIIT training. And I'm going to just tell you right now, these are young adults for the next two slides, because that's as far as we've gotten so far. We're moving to kids, but it's going to take us a little time. And actually, Dave's going to help us with that. And so this here you can see is 3 bouts of high-intensity interval training. It's a 1 minute on, 1 minute off. So 1 minute at a very high dose of activity, followed by 1 minute at a low dose of activity, high, low. And that's quite a long dose. These are young adults. In kids, we go more to a 30-second model. Here you have continuous aerobic exercise, and here's our rest condition. Interestingly, if you just stick over here, we've replicated. Here's our greater P3 amplitude, greater activation after continuous exercise compared to rest. HIIT shows a decrease in activation. And so that's rather interesting because it's not showing an enhancement, it's showing decrease in performance, in activation. It would make a lot of sense if their performance was also decayed, but actually that's not the case. I'm just going to sort of cut to the chase and show you here. This is HIIT training. This is accuracy in the executive condition for HIIT relative to relative to continuous aerobic exercise and rest. So they actually perform better. And when we look at reaction time, you can see that we replicate again that continuous is different from rest, but HIIT is better than continuous. And so it appears that HIIT is even better than a single bout of continuous aerobic exercise. Less time and greater benefit. So we replicated it. Oops, I seem to flash through this way, so don't make myself crazy. Here is, you can see it's a longer HIIT. One argument that we could have had is that, well, we adjusted both intensity and time. Which might it be? Here's our attempt to show you that it's not just a difference in time. We gave them a long HIIT session. We made it tiring. We yoked it to the continuous aerobic exercise and to the rest conditions. And we replicated less activation, more activation compared to rest. When we look at performance on that inhibition task or a working memory task, what we see is that HIIT and aerobic exercise perform better than following a bout of rest. And when we look at that working memory task, we see that HIIT outperforms rest and aerobic falls in between. And so again, there's benefits to inhibition and working memory following very high intensity doses of exercise for short periods of time. And then just quickly, I want to show you work from other people's labs up in Canada. Here's work by a colleague of mine, Brendan Gerd, and then work by Dave Lubin's lab. In both cases, we see that in the classroom, we're seeing changes. We're seeing that HIIT is related to less time spent off task following a HIIT session. And over here, we see that HIIT is related to better executive function, again, in relative to, well, these are both HIIT sessions, but this is a stronger HIIT session in terms of how it was designed. And so with that, I'm going to switch gears, talk about Scholastic Performance for a minute. It's great when you have a laboratory full of equipment and you can bring kids in the lab, but that's not real world, and we get that. And so one thing we try and do is get a little bit closer. And so I'll give you 2 examples of how we try and get a little bit closer, and then one example that's much more applicable to sort of the way in which children learn. So we're interested in language processing. We're not just looking at fish or arrows and trying to make decisions. Instead, we ask kids to read sentences. Those sentences are either congruent, you wear shoes on your feet, makes a lot of sense. They read sentences in which there's a semantic error. At school, we sing, shoes, and dance. Or they had a syntactic error, you shoes, wear on your feet. And we looked at a different potential called the N400. The N400 is involved in sort of semantic aspects of learning. That is to say that it's involved in sort of the lexicon or kids' ability to recall words and understand their meaning. And what we see is that high fit kids have greater activation of that N400 potential than lower fit kids. We see that it's there for semantic and syntactic errors as well as for when sentences are congruent. When we look at the latency in which that potential develops, again, we see that higher fit kids are processing information more quickly. When they make, and that's for semantic errors. When we look at syntactic errors, we see something called a P600. It's similar to the P3 component I showed you before. And we see that there's greater activation there as well in the brain of high fit compared to low fit. But what's interesting is that when we look at their performance, you can see that high fit perform more quickly on these decision tasks of whether or not an error has occurred. They're more accurate, although not significantly so. But they also perform better on academic achievement tests of reading and spelling. And so again, we're showing you evidence for brain function, cognition, and achievement between high and low fit kids. And we did this again with a math task. So this math task, we asked them to problem solve. It was an arithmetic verification task. 2 plus 3 equals 5, yes or no. So if we said 6, it would have been no. And then there are big and small problems. This is a small problem. A big problem might have been, say, 12 plus 13 equals 25. And what we have here is the first thing we found is that higher fit kids use differential strategy on large problems than lower fit kids. Lower fit kids tended to rely on counting strategies, where higher fit kids rely more on a clustering strategy. So in the 12 plus 13 equals 25, it might have been, higher fit kids report a strategy of 10 plus 10 is 20, 2 plus 3 equals 5, that kind of thing. We find that they also perform better on large problems compared to lower fit kids, no differences in the small problems, and I don't have the nice maps, but you can see that they have a significantly larger N4 component than lower fit kids. And so again, it's not just related to reading achievement, but we see it in mathematical performance. We see that higher fit kids have some advantage over lower fit kids. Now, the last study I'm going to talk about today, before I talk a little bit about what I'm actually doing here or what I was doing in Newcastle, is a study in which everything I've told you about thus far has to do with cognitive performance. That is, how well do kids perform? But we don't know if they actually learned anything. We just know they performed better. And so one of the areas we want to jump into is learning. And here we have we had high and low fit kids, approximately 25 per group. And we asked them to come in and learn a map, or learn a couple maps. And these are fictitious maps. We made them up. And in one condition, they'd sit in front of an iPad. They would see 20 regions. 10 of them would get a name. And they'd simply tap the region that they had seen it. So in this case, they tapped that Taft is this second region from the right. And the other condition, it was a test study condition. We gave them a strategy in which to try and learn this information. It would appear over here on the right, and then they would tap the region in which they thought was named that name. So clay would be all the way to the left. Now, obviously, in the beginning, in this test strategy condition, they didn't do very well. It was a guess. First time through was a guess. Second time they get a little better, so forth. And when they left the lab, they would tap where they thought it was, and then the computer would actually or the iPad would show them where it actually was. In this case, the kid got it wrong. When they left the lab at the end of the first day, over the course of learning that information over 6 blocks, so 6 times through, what we saw was that high and low fit kids were able to encode that information equally well. They learned that information equally well when they left the laboratory on day 1. When they came back a day later, so all kids came back 24 hours later, and we asked them to recall this information, they were asked to recall it one of two ways. They had to recall it by either just remembering it off the top of their head and typing it in, so a free recall, or they were given the information at the bottom, they were cued, and they could use that to then type in and answer the name of each region. And so we had two ways to encode, two ways to recall, and what we found was that high-fit kids outperform low-fit kids. They had better memory only in the study only condition. When we gave them a strategy to how to learn it, we saw not only they all performed better, not only did everyone perform better, but there's no differences between groups. But when left to their own devices to remember that information, higher fit kids outperformed lower fit kids on what you can tell is a relatively hard task. And when we broke it down and looked at their performance, as a function of recall, what we see is that in the hardest of conditions, the study-only condition and the free recall, when they had to remember the name of each region without any sort of help, that's where the largest effect occurred. Now, it turns out that recall is fairly important because in that test study condition, we also see that, when they had to recall it from memory, that we also saw a smaller difference there as well. So we're actually replicating this study right now in the magnet, in an MRI, in order to look at brain function associated with recall, so on the second day in which they came in. Hopefully those data will become available soon. And with that, I want to change gears once more and talk about the Burn to Learn study. This is a project that's being led by Dave Lubens. And also, I certainly like to point out Professor Chris Lonsdale, who's here at Australian Catholic University. And this is a team overall. The vast majority are coming from Newcastle, exception of myself and my doctoral student Tatsu, who's here in the audience today as well. And it's funded by the National Health and Medical Research Council, as well as Department of Education of New South Wales, the school sport unit. And the rationale for Burn to Learn is that, and I don't have to tell you guys this, I learned a bit of this along the way, is that the HSC is a stressful period for students. This is obviously not similar to the US education system, but it's been reported that 1 in 5 Australian teenagers experience high psychological stress around this time. And we know that physical activity improves mental health. But we also know that physical activity declines during this period of the lifespan. And as hopefully I've already made this argument, as hopefully I've done so effectively, vigorous physical activity is essential for cognitive and mental health. And so that's our rationale. Burn to Learn is a school exercise program for year 11 students. It involves participation in 2 to 3 peer-led HIIT sessions each week. And schools receive a suite of free, purpose-built resources to support the program. And you can see some of those resources off here to the right, as well as some will be through an app, right? And so currently we're recruiting schools for this large-scale study. And the goals of the study are to show the impact of HIIT, of vigorous physical activity, on students' cardiorespiratory fitness, body composition, mental health, cognition, and brain health, areas that I've just spent the last 45 minutes or so talking about. And so if you're interested in this, certainly you should speak to Dave or Chris, or you can jot down Jordan's or Jordo's information, who's jordan.smith@newcastle.edu.au. And so with that, let me just conclude today. Fitness is related to differences in brain structure and function. I hope I made that argument effectively, that both brain structure and function benefit due to differences in fitness, or as a function of differences in fitness. And it's been linked to changes in cognition that are disproportionately larger for tasks that require greater amounts of cognitive or executive control. So we showed selectivity in a bunch of our data. So time spent engaged in physical activity doesn't detract from academic performance, as many schools or districts believe when they cut physical activity opportunities from the school day in favor of more academic time. Single bouts of physical activity have appeared efficacious to improve cognition, and that period lasts for approximately 1 hour. It's a little bit gray as to when it begins and when it ends, but I feel safe saying that certainly from about 5 to 10 minutes post-exercise till about 1 hour, we see our relationship. And schools are well placed to improve children's health behaviors, not just improve their academic behaviors, but also their health behaviors. And so certainly early school-based intervention to promote health behaviors is crucial for lifespan health and effective functioning of brain and cognition, not just during children, but during the entire lifespan. And so with that, I'll leave you with this. I could have just concluded by saying this is a cartoon from the New Yorker. I've been working out for 6 months, but all my gains have been in cognitive function. Kind of hope that our work was able to generate this cartoonist idea. And this is my group. These are my colleagues over here, my funding agencies, sort of the postdocs, the students, people do all the heavy lifting. And so with that, thanks for your time. Be happy to take any questions.
How many schools are you after for Learn to Learn?
About 20 more, about 20 schools. Mm-hmm.
And Merriweather's in already?
Merriweather and Katara are in our pilot study, which we're running this year. And then starting in 2018, we'll have a cohort of 10 and then another cohort of 10 all the year after.
Louise?
Oh, hi.
Hi.
Thank you. Great talk. I can't call you Chuck. I'm a child abuse epidemiologist at Sydney Uni, and one of the things that happening within our state is, we've only got about 15% of adolescents, about 25% of kids are reporting that they make 60 minutes of physical activity a day. And interestingly enough, you can ask them, what are physical activity guidelines for children, and only about 40% of children and parents of young kids know that. I'm wondering with what you guys are doing, so this is also including you, Dave. So in terms of focusing on the kid, and I mean, I'm out there for getting kids moving because they're not moving. But I'm just wondering, are you doing any sorts of risk management in the kind of in ensuring that just because you run on the spot for a minute, just to that in a nutshell, is good for your health when we know that we're needing that longevity for all of the other, say, bone health is one thing I'm just thinking
Sure.
about at the moment. Because my fear is, if you go back to work with James and I about 10 years ago, who said you only need to do 1 minute of physical activity for health benefit, and everyone recalls that, but no one can recall how many minutes kids should be doing. So my question is,
We both can, it's up to you.
something there to ensure that the populations don't start to say, we need to do something.
Yeah.
So I mean, what I would argue, first of all, is that there's a much broader literature on the physical benefits of HIIT over the cognitive benefits. There's actually only about 5 papers on the cognitive benefits for HIIT, but there's a much broader array of evidence for physical benefits, including cardiorespiratory. Let's see, there's both molecular and cellular effects. So you're talking mitochondria, sort of the energy center of the cell. But the other argument or the other thing I would say, and then I'll let Dave take a whack at this also, is that one type of exercise isn't enough in the sense that we talk about cross training and being engaged in a physically active lifestyle. Being engaged in a physically active lifestyle doesn't mean performing 2 to 3 HIIT sessions a week in class in order to derive a benefit for that individual in the classroom, right, or in a broader way. That involves also being in a physically active lifestyle outside of school, right? And so while HIIT has benefits, we also know that continuous aerobic exercise has benefits, right? And so HIIT also isn't not just running in place. It also involves muscle building exercise such as push-ups and and it could be jumping rope vigorously. It can be done, the beauty of it is it can be done a whole bunch of different ways, some of which would include bone loading exercises, jumping up and down, things of that nature.
So I start by saying that I'm not suggesting for a second that he's going to solve that problem of inactivity for the population. It is one important tool that we do want the whole population to be aware of the benefits. So we're specifically targeting year 11 students because we know that time for this is designed for students who for the most part have kind of drifted out of organised sport and activity because their parents or their teachers are saying, hey, you guys are you stop that sport, you've got to focus on your study. So we are giving them some skills and a dose of activity that can get them through a tough period of life. And I don't think for a second that they're going to do 2 or 3 sessions and hit for the rest of their lives, but if we can get them through that time, let them experience the benefits of that type of training, and then maybe they can still acknowledge that and pick up a session here or there when they go for a walk on one day, go for a surf on another day, little hit session here when they're running time for, that's wonderful. But it's really important. The last thing I want to say before I give Mike back to Chuck is that our hit is not sitting on a treadmill and flogging them for minutes on end. We have dance here, we have sport here, we have gym here, we have a whole variety of styles of hit that is designed to be engaging for students. And as much as the activity should be doing, we're really focused on creating an environment that the students like and they want to come, they want to spend time with their friends doing it. So absolutely agree with you, Lou. There's so much confusion around there. We are trying to help students get a time in their lives that we know they will be struggling. Giving them something that we know they do it, that's the big if, and that's where we have to work on. If they do it, we will see benefits.
It's also probably a pretty realistic statement you made about about all they remember is that 1 minute, right? Because as we all talk about, children should get 60 minutes or more of moderate to vigorous physical activity every day, right? But actually, it wasn't until I joined the Physical Activity Guidelines for Americans 2018 committee that I realized there's more to that statement. You know that the rest of that statement is that kids should also get additional time spent in bone loading exercises. And I've been around this literature for 10 years of that, and since the last one came out, I didn't know the rest of that statement. So it's true. People only remember that little bit that they want to. So.
Ross, you wanted to add to that?
Yeah, I just wanted to ask a question, but I also wanted to talk about the HIT. The HIT idea from the school sports unit's point of view is really only related to senior students. It's in no way supposed to be related to a be and an end all for all students or all people around physical activity. My question to you, Chuck, is in relation to strategies to change leadership models in education to making them understand the benefits of physical activity for students in the school space. Are there anything happening there that is working, any successful strategies in convincing principals and school leaders on why they should be doing more physical activity?
Right. I can only really speak from the experiences I've had with specific schools or school districts, because this isn't exactly my area. I'm an egghead who sits in my laboratory and plays with imaging devices. But at least in the U.S., the groups I've worked with there, certain ones, the ones that are driven by, typically it's driven by like a really motivated PE teacher who then goes to a really motivated administrator, and together they look for evidence based on my work or others, and then they try and really drive it through the school or the school district through teacher in-service days and things of that nature. The one that's probably been most successful in the U.S. is Naperville, Illinois, and they've done so by creating a 0-hour PE class. So there's this notion of 0 hour where the kids come to school, and this is high school age kids, but they come to school an hour early, and they open up this is a wealthy school district, and so they open up the PE space, which is really like a health club. I mean, it's cycles and treadmills and all that. And they allow kids access to this, and the kids who want to do come in and do it. And their evidence is that Naperville is among the top 10 in the nation in academic achievement. But there's certainly other factors at play there, like socioeconomic status. I have been in contact with some people in Denmark. And they actually, Denmark has changed their entire model. They now have built in through their federal education offices that there's daily mandatory 1 hour of physical activity every day in school. So different places, have different approaches, I would say. But there's good examples.
I would say in terms of Chuck's work, I think it has the potential to really drive change. When you see this sort of stuff, which is quite compelling, and we're trying to get, obviously cognitive benefits is one of many.
Mm-hmm.
Obesity prevention is obviously another one. One of many outcomes we're going to get at children being more active. But when schools think about what's their core business, it is about academic achievement. So the type of work that Chuck's been leading, I think, can be really influential if we get it to the right people.
Yeah, I had a question.
Sure.
My name is Leanne. I'm a principal and I'm also a PE teacher.
Okay.
My question of you is, have you done any studies around children with intellectual disabilities and any effect it has on them?
The only study I did, I've showed you, which was the ADHD one. One of my main reasons of leaving the University of Illinois is that it's a large school in the middle of a small cornfield, and or say a large campus in the middle of a very large cornfield, and there just isn't the population, and so I have not had that ability to do so in terms of cognitive disabilities. One of my goals for moving to Boston is that I'm going to have much more of an opportunity to engage in projects around defiance disorder, which actually I have a meeting on that next week with a group who does that, autism, spectrum disorders, and more ADHD work. And so that was one of the reasons. Now we certainly, and I didn't show any of these data today, I could have spent an hour talking about one of my other areas, which is adiposity. And so looking at obesity and its relationship to brain structure, brain function, and cognition. And that also has become a disability, at least in the United States. And we do see dramatic changes in brain and behavior, as well as academic achievement, as a function of being morbidly obese as a child. So more to come. But overall, across the literature, I'm not aware of any studies on autism yet, just a very small handful of ADHD studies. And that's certainly an area that needs to be up and coming. So, yeah.
Follow up on that question, a bit of that point. From your experience, what seems to be stronger in terms of association for the athletes experimentally, fitness or adiposity as it relates to academic and cognitive function?
Yeah, so that's a good question. We've approached that a number of different ways. Several of our papers and data sets have shown that actually they have differential effects, on different aspects of cognition. The papers that we've been turning out most recently, so if we're going to look at just an adiposity model, we have to control for fitness because we know there's a relationship there as well. And being overweight, actually, if you want to, on a VO2 max test to measure oxygen consumption, which is a gold standard measure for fitness, if you can't increase your output and you cut weight, you actually improve your score. And so, because it's a relative based on body weight, it's a relative measure. And so we actually have to control for fitness. And when we do that, we still see an effect of adiposity. Now, that effect is quite small. But what I would argue is that in both cases, the effects are quite small in our models, but that's because we control for IQ. And IQ has a whopping amount of variance that's associated with it, as much as 50% in a lot of our models. So the fact that we see either of those on top of IQ is actually quite impressive to me. But to get directly to your question, it's a moving target. I'm not exactly certain. I can tell you that we now have multiple data sets showing that when we use DEXA to image body mass and break down adiposity fat, you can break it down a couple ways. You can look for regions of interest, and what we show is that central adiposity tends to be worse than peripheral adiposity. And we show that fat is stored two ways, either subcutaneously under the skin or in the visceral cavity. It's called visceral fat. That's what surrounds your organs. And visceral adiposity is especially metabolically demanding, and that appears to have a much larger effect on cognition than subcutaneous adiposity. So, and don't ask me how you store one over the other, because I don't know. It's people store it both ways, and you need some fat, right? Some fat's healthy. So, yes, sir.
Yeah, my name's Ted Noon. I'm also a principal and supervisor for some long-standing PhD work.
My apologies.
And I'm a PE teacher as well, and I've had a great interest in the work that you do, and
Thank you.
I've certainly had a look at that as of course with Dave. Dave only knows too well the big picture part of my work, and just in relation to Ross's question, the normative we know of in terms of obesity and overweight and the issues, even in first world countries like Australia, as much as we gloat about how well we're doing internationally and economically and so forth. But when it comes down to it, and many of us, some of us here work in some of the most disadvantaged areas in Australia, and I would equate them with some of the worst in the world, even though we're this great first world country. Altogether though, when we look at those figures of obesity and overweight, it's quite horrific. And my interest and work as a leader of many years is just how do we affect that change from that leadership level. And the principles, as many as I talk to, glaze over because of the pressure of what it is they're expected to fit in what basically is about 12% of time spent in schools in a child's life. 12%, the rest is home, sleep, whatever else. But I still think, coming back to the responses that Dave gave himself, that the data, time is of the essence. Where do you fit this in? And something like high impact is going to have an impact, I suspect. And having a champion or champions at local and state level, and a community approach from certainly the work that I'm seeing. If communities can come together with some of those champions and show those at the top, the national and state level, that you can actually do this, but it requires you showing the data, showing that you can create this time. And if a community can come together as networks across Australia, say here in this country, I suspect, certainly from my reading of it, that that's a way of moving forward. And to dog Chris in here, Chris is president of the New South Wales Secondary Principals Council, and he's here through this work that you're talking about. And I know he's nodding his head in terms of how do we also tag onto the fact that New South Wales has one of its priorities around obesity, I think, this year, hasn't it? And linking in with the Melbourne Declaration, which says that schools are expected to promote, an interesting word, the physical, mental, spiritual, intellectual. That's in our national agenda. But the question will be, what are we doing in terms of accounting for that?
Well, you know, my initial response is to this long statement is that, I mean, I think that's where Burn to Learn is so well placed. You know, if at the end of Burn to Learn, or at the end of our pilot work, we can show that there's benefits to the individual at no cost to educational attainment, well, maybe it's worth rethinking the school day. We're not asking for an hour, right? We're not asking for 30 minutes. We're asking for 10 minutes, 3 days a week. And, you know, that's a small dose, right? There's no doubt that if we can get a large dose of exercise in there every day, there's a ton of physical benefits that kids will gain from it. But that appears unrealistic. I'm yet to find a school or a school administrator who's going to say, yeah, you can have an hour a day, right? Apparently, only Denmark has figured out how to do that. And so it might be worth seeing how they did that. I don't know if they extended their school day, I'm not sure. But if Burn to Learn, you know, or programs like it can offer, you know, 30 minutes throughout the course of a week, and there's benefits to that individual, I think there's reason to rethink things, you know, a little bit anyway.
And Dave, I think that variety that you're talking about too, in the approach, you know, through the dance and so forth, does get it off that notion of just jumping up and down on the spot.
And it's not about replacing health and physical education in the curriculum where they're learning a variety of skills and sports and activities that are going to take them in different directions. This is a period of their time when we know there's all the time, but the schools are trying to fit everything in. It's about efficiency.
Yeah, you know, what I'd also say is that, you know, if an individual feels they derive benefit from something, they're more likely to practice it on their own. They place importance upon it. They now gained efficacy to perform that behavior. And they, you know, they might do it at home. And then it's on that individual who brings it back to their family or their community, and they get others to do it with them, right? So, I mean, you know, it's as simple as anything else. I mean, my son shoots 500 hockey pucks a day in the garage. He leads his team in scoring. There's an obvious correlation there, right? The rest of his team's not shooting 500 pucks a day. It's pretty straightforward. So.
You must have
Bring it on, Lou, we're waiting for it.
No, I suppose I was just listening to this, and you know that I think it's a great program, Dave. I think we also have to be very careful that the onus of getting kids to be physically active is not the remit of education.
Is not what?
The remit of education only. Yeah, there's so much is always placed on the schools. I'm not from education, I'm from the other side, health, that seems to think that we should be telling education what to do. But we really do need to ensure, and I'm glad you just mentioned it at the end, about community, parents, ensuring that the environment actually supports anyone to be physically active.
Yeah, so we actually learned that in our Fit Kids study because most of those kids were from pretty, not all, but I mean certainly a good percentage from disadvantaged backgrounds, and we knew that they came to us for 2 hours a day and they received a healthy sort of part of their day, but they were going home to a world that was sedentary in front of the television and eating poorly. And the question is, how much impact do we have on that child's life over the course of a lifespan, right?
Can I just ask you that first, but where do you actually do the sessions? Are they done before an exam, or are they done?
Well, this is where the flexibility, and what we've realised with all sorts of school-based research, it's going to be flexible. So we've designed it so the schools can implement it through PDHPE, they can implement it through SLR sports games, they can deliver it at lunchtime, they can deliver it after school in the sport period. It's designed that we kind of train leaders within the school to assume responsibility for running all sessions, and that's really how it works. It could happen before exam. Some schools would see the imaging evidence around that activation and say, hey, this is what we'll do on the days when they are leading into exams. We know that happens in some primary schools. But the key about all of the school-based work we do is the need for flexibility so that principals, the teachers can make it fit within their own framework.
It's just interesting just to build on it to that, because it's like a brain warm-up.
Hmm.
Like a powerful brain wash. So what about,
Yeah.
like it's so important with HSC that that plan is the biggest data and that plan. But 10 minutes of the hit before that plan is.
Anecdotally, I know of schools that do that. I don't think there's been any systematic,
Right.
I understand, systematic approach to trying that technique. But I know anecdotally that some principals go, hey, we don't even need to see chunks images. We know that our kids are more switched on after they've been active. So obviously, I think even though this Bernal is one small study really in the scope of what Chuck's doing and something that's being done around the world, even for us to just sort of start to get evidence around this, it's just another thing that kind of pops up and provides attention and a reason why schools should be doing any kind of activity for their students. Again, I'm not just a hit actor. There's all kinds of different activity that we should be providing.
Pre-exams, it's just such a good thing, like just to be very physical that 10 minutes before. It's about stress management.
Mm-hmm.
Elite athletes do all the time, warm up, we go out with.
Right.
That connection in this domain will speak volumes because it's all about academic performance. But if we get the door,
I think schools will do that.
yeah.
Chris.
I just wanted to pick up on what you were saying there, Lou, and also speak to the principals who are in the front row, not surprising.
It's only because we figured everyone else is sitting there.
And I couldn't agree more that it's not only the responsibility of schools, but schools provide such a venue and an opportunity for communities and parents and educators to all come together. So I mean, in a lot of the work that we're doing, we are trying to get that whole of school, whole of community parent approach. But the school is the place. It's really the only place in our society where you can access all of those groups at once, and because where most kids go to school. So I think the responsibility isn't just on educators, but it's that opportunity and that venue, so that if we can do it in a way that's not too burdensome for teachers, because that's the biggest thing we hear when we work in
Right.
schools is about time, priorities, and so on. So if we can provide those ways, it's the ideal venue in which to provide those opportunities for those different stakeholders to come together.
And parents place an importance upon school, right? And so they trust the schools to educate their kids and keep them healthy, right? In that regard.
And a lot of what we're doing, especially in primary schools, is about fostering the teachers' advocacy. So many of our teachers who are our generals don't have that background, and so we're helping to provide that. And so many of them, I mean, we have some incredible quotes from primary
Chris, actually, one point I want to make from what you said is that what's good for the goose is good for the gander, right? And so I got up here and talked about kids today, but there's actually a much larger body of literature on physical activity, brain, and cognition in older adults and young adults. And so actually, someone needs to put together an intervention where we're not just providing a dose of exercise to the kids, but we're providing it to the teacher as well, right? So everyone in the classroom is getting it.
I suspect too that when I was talking about community approach, just picking up on what you're saying, Chris, schools are the best place, they are. But I also think with the previous comment that health working together in a community approach, because I know in certainly South West Sydney, but probably across New South Wales, there is the one-stop shop operation is now becoming more the case, that is a more integrated approach. So there's not much point health, for example, working on mental health and educators working over here on mental health in another way. But if health come aboard, then that also helps to perhaps assist schools, and not feel that schools are the only place that this is going to happen. I think there's some movement there, and certainly interest in mind, how you integrate services, not replicate, and at the end of the day you end up saving money as well as children's health.
That's right.
Thanks, Ted. Any other final questions? I might just put a little plug in for Chris at Free Catholic Uni. One of the programs that we've been working on is a primary program called iPlay for public schools, and we hope to roll that out in a little bit more detail coming up. Chris is doing some terrific research there, but just opening that up a lot more for primary teachers in particular, which is really exciting, and it's absolute quality stuff, which I'm so pleased to be involved in. Can I just thank you so much, Chuck, for just giving up your time. It's been wonderful, and the assets that we'll get from this we'll certainly share, hopefully with people further up the food chain than myself, to get some real traction for public school kids in New South Wales.
Thank you.
Can I also thank you for coming in, engaging, asking the questions. Friday afternoon is not a good time for anybody, so I really do appreciate I guess, your passion around this area. I've been involved in this game for a long time, really passionate about it as well, and it's just great to have advocates like yourself, having access to this quality of data. We've got a little present for you, Chuck, to take back. He told me he's up the pointy end of the plane tomorrow.
Thank you very much. I appreciate it.
It's a koala bear.
Nice. Thank you.